So if you, or maybe someone you know, has ever heard that diagnosis, treatment-resistant depression, well, you know how incredibly frustrating that feels.
Absolutely. It's like you've done everything right, tried the standard meds, but nothing's really sticking.
Exactly. And the usual story just stops at, brain chemistry, maybe lack of serotonin.
Right. But today, we're going way beyond that. We're looking at a whole systems thing, drawing from this great four-part series, Conquering Resistant Depression.
A systems thing, what does that involve?
Well, it shifts the focus. We're talking genetics, we're talking gut health, chronic inflammation, things that might be the real drivers.
Okay.
Our goal here is really to unpack the science behind this so you can have much more informed conversations with your own doctor or therapist.
That's crucial. And speaking of doctors, before we really dive deep into these concepts, some are pretty technical. We absolutely need to cover our standard medical guidance.
Yes, definitely. We have to be super clear.
Oh.
Everything we discuss today is purely for educational, informational purposes. Okay. It is not a substitute for professional medical advice, diagnosis, or treatment from a qualified healthcare provider.
Yeah.
Depression is serious. It needs professional care, period.
No doctor-patient relationship here.
None whatsoever. We aren't giving personalized recommendations, and this doesn't replace seeing a licensed mental health professional.
And critically,
Never ever stop or change any prescribed medication without talking to your doctor first. Always consult the right professionals before making any changes to your health routine. We're just exploring the research, trying to shed light on possible root causes.
okay, perfectly clear. So let's get into this roadmap. You mentioned genetics first. Something about a specific gene.
Yeah, this is fascinating. It's called the MTHFR gene variation. An estimate suggests it affects a huge chunk of the population, maybe around 40% of Americans.
40%. Wow. So what does MTHFR actually do? Or maybe what's it supposed to do?
Okay, so MTHFR stands for a long name, methyltetrahydrofolate reductase. Forget the name. Just think of the gene as the instruction manual for building a specific enzyme, a little factory worker in your body.
And this worker's job.
Its main job is to take regular folate vitamin B9 from food and convert it into the form your body can actually use, the active form, L-methylfolate.
L-methylfolate. Okay, why is that specific form so important for, say, mood?
Because L-methylfolate is basically essential fuel. You need it to make your three main mood chemicals: serotonin, dopamine, and norepinephrine.
Ah, okay, so if the MTHFR gene is faulty, the factory worker isn't doing its job right.
Exactly. The conversion process gets sluggish, sometimes really inefficient. Your body struggles to make enough of that active L-methylfolate fuel.
And genetically, what does faulty mean here? Are there specific types?
Yeah, there are two main variants people talk about: C677T and A198C. If you have one or both of these, the enzyme's ability to do that conversion can drop significantly, like 30% to maybe even 70% less efficient.
70%. That's huge. It's like the factory is barely operational.
Pretty much. And the research really connects this directly to depression. We saw a great paper, Treatment-Resistant Depression Revisited, a glimmer of hope.
What did it say?
It spelled it out clearly.
Yeah.
These MTHFR variations, or polymorphisms, they lead to less L-methylfolate being made, and that directly leads to lower levels of dopamine, norepinephrine, and serotonin.
So if you're naturally struggling to even make these chemicals,
Then standard antidepressants, which mostly just try to recycle what you already have, might not be enough. They can't fix the fundamental production problem.
that makes a lot of sense. So testing seems like a really important step then. Is it hard to get tested?
No, not at all. It's actually quite simple, just a blood test that looks for those specific gene variants.
And doctors are doing this more often?
Increasingly, yes. Especially psychiatrists dealing with treatment resistance. There's another paper, Genes Guide L-methylfolate Adjuvant RX for treatment-resistant depression, which basically supports using this genetic testing to guide treatment more effectively.
Okay, so if the test shows the gene isn't working right, what's the fix? Can you get around the faulty factory worker?
Yes, and this is the elegant part. You essentially bypass the problem. If your body can't make the active L-methylfolate efficiently.
You just give the L-methylfolate directly.
Exactly. You supplement with the already active form. You supply the finished product instead of relying on the broken conversion process.
That almost sounds too simple. A supplement for a genetic issue.
Well, it's not a magic cure-all, obviously,
Err.
but it targets a very specific problem that's been identified.
Right.
And studies, like those mentioned in L-methylfolate in patients with treatment-resistant depression, have found it can be a really helpful adjunctive treatment, meaning you use it alongside other therapies.
Okay, adjunctive, got it. What about food? Can diet help?
Definitely. You can support the whole methylation pathway with nutrient-dense foods. Think things like chicken liver, beef liver. They're packed with naturally active B12, choline, and natural folate.
Natural folate, not folic acid.
That's a key distinction. The synthetic folic acid added to lots of fortified foods, like white bread and cereals. It still needs that MTHFR enzyme to be converted.
Ah, so if you have the variant...
Those fortified foods might not be doing you much good in terms of getting active folate. You need the real deal, or the L-methylfolate supplement.
Wow. Okay, that's a huge point about synthetic folic acid. So we've covered the genetic piece, the raw ingredient problem, but where does serotonin actually get made? You mentioned the gut earlier.
Yes, let's shift there. We need to talk about the gut, the body's second brain, and this constant communication highway it has with the actual brain. It's called the microbiota gut-brain axis.
The gut-brain axis, and the main communication line is...
The vagus nerve. It's the superhighway connecting the two.
I always thought signals mostly went down from the brain.
That's what most people think. But actually, about 90% of the signal traffic on the vagus nerve goes from the gut up to the brain.
90%. Seriously.
Seriously. There's research on this, like in recognizing the role of the vagus nerve in depression. It shows how signals from your gut bacteria travel up this nerve and can directly influence brain function and mood. The gut is constantly telling the brain what's going on downstairs.
Okay, mind blown a little. And this leads to that shocking fact about serotonin.
Exactly. The biggest shocker for most people. You think serotonin, you think brain chemical, right?
Yeah, totally.
But roughly 90%, 0% of your body's entire serotonin supply is actually produced in your gut.
Get out. 90% in the gut.
Yep. By special cells in the lining of your intestines. There's a study called Gut Microbes Promote Colonic Serotonin Production that confirmed this. It's made right there.
So if my gut health is off, my main serotonin factory is basically offline?
Pretty much. That's a massive implication. And what throws gut health off? It often starts with dysbiosis, an imbalance in your gut bacteria.
From what? Stress, bad diet, antibiotics?
All of the above. Infections, too. You lose the good guys, the beneficial bacteria. Then, if the gut lining itself gets damaged, you end up with what people call leaky gut, increased intestinal permeability.
Leaky gut sounds bad.
It is, because that's the trigger for the next big problem, chronic inflammation. When that gut barrier breaks down, stuff that should stay in the gut leaks out into your bloodstream. Toxins, undigested food particles.
And the body freaks out?
Exactly. The immune system goes on high alert. It starts pumping out these pro-inflammatory signal molecules called cytokines, things like IL-6, TNF-alpha. They're messengers yelling, danger.
And these messengers, they travel. They don't just stay local.
Nope. They can cross the blood-brain barrier. They get into your brain.
Uh-oh.
And this is where inflammation pulls off what I call a devastating chemical hijack. It involves something called the kynurenine pathway.
Okay, the kynurenine pathway hijack. Break that down. What's happening?
So think of tryptophan. It's an amino acid, a building block. Your body can use tryptophan to make either serotonin, the good mood stuff, or it can convert it down this other pathway, the kynurenine pathway.
Okay, a fork in the road for tryptophan.
Exactly. Now, when those inflammatory cytokines flood the brain, they basically force tryptophan down the kynurenine path. They trigger enzymes that do this conversion.
So instead of making serotonin...
It gets turned into other things. And some of those things, like quinolinic acid, are actually neurotoxic. They can damage brain cells.
Wait, so inflammation makes the body use the serotonin building block to create brain toxins instead?
That's essentially what happens. It's a survival mechanism gone haywire in a chronic state. There's a paper, Role of Kynurenine Pathway and its Metabolites in Mood Disorders, that explains exactly this, how inflammation basically steals the tryptophan needed for serotonin.
So no wonder SSRIs might not work if the raw material is being diverted before it even gets to the serotonin production line.
Precisely. You can try to recycle the little serotonin you have, but if the building blocks are being hijacked by inflammation, you're fighting a losing battle.
And does anything else worsen this gut inflammation issue?
Oh yeah, we should definitely mention fungal overgrowth, like candida. That can seriously damage the gut lining too, fuel even more systemic inflammation, and just generally mess up the whole neurotransmitter balance.
Okay, this is a complex picture. MTHFR, gut dysbiosis, leaky gut, inflammation hijacking tryptophan. So if these are the roots, what's the plan? What are the actual healing strategies?
Right, let's talk action. The first one sounds almost too simple, but it's powerful. Physical activity, exercise.
Exercise is medicine.
Truly. Exercise boosts something called brain-derived neurotrophic factor,
BDNF.
BDNF, that's the stuff that helps grow new brain cells, right?
Exactly. It helps grow new neurons, particularly in the hippocampus. That's a brain area crucial for mood and memory, and it often shrinks in people with chronic depression or stress.
So exercise can literally help rebuild parts of the brain damaged by depression. That's the idea. Research like exercise-mediated neurogenesis in the hippocampus via BDNF supports this. You're promoting repair. The goal: aim for maybe 30 minutes of moderate aerobic activity, brisk walking, jogging, cycling most days of the week. Get that heart rate up.
Okay, gotta sweat to grow brain cells. I like that framing. What's next?
Sunlight. Good old-fashioned sunlight.
How does that help?
It activates your pineal gland, which plays a role in triggering serotonin release. Plus, it helps your body make vitamin D, which is also linked to mood.
How much sun are we talking?
Not hours baking. Just 10 to 30 minutes of exposure on some skin most days, if possible, can make a real difference.
Simple enough. Okay, exercise, sunlight. What else?
Cognitive behavioral therapy.
CBT.
Talk therapy. How does that fit into this biological picture?
Because it's not just talk therapy. It physically changes your brain. There was fascinating research reported in translational psychiatry. So, exercise, sun, CBT, and an anti-inflammatory diet focused on omega-3s, olive oil, and plants. That's the positive action plan.
That's the core of it, yeah.
Now let's flip it. What do people need to avoid? What are the things that sabotage recovery by fueling that inflammation or messing up the gut?
Okay, critical list here. Top of the list. Ultra-processed foods and added sugars.
The usual suspects.
For very good reason. High intake is directly linked to higher rates of depression. They are rocket fuel for chronic inflammation.
And sugar does more than just cause inflammation, right?
Yeah.
Didn't you say it affects that pathway?
Yes. Sugar directly messes with the kynurenine pathway, pushing tryptophan towards those neurotoxins. Plus, it devastates your good gut bacteria. It's bad news all around for mood.
What about artificial sweeteners? People often switch to those. Are they okay?
Sadly, probably not. Things like aspartame, other non-nutritive sweeteners, the research is showing they can disrupt the gut microbiome too.
Really? Even with no calories?
Seems so. And some studies suggest they might even affect gene expression related to neurotransmitters in the amygdala, the brain's fear center. So probably best to avoid them if you're working on mood.
Okay, noted. What else is on the avoid list? This next one sounds serious.
Yeah, this is a really important one to discuss with your doctor. Quinolone antibiotics, sometimes called fluoroquinolones.
Why are they a concern?
They come with black box warnings in some places for serious neuropsychiatric side effects. We found research in psychiatric disorders associated with fluoroquinolones that documented reports of depression, psychosis, sometimes kicking in really fast, like within 2 weeks of starting.
Wow, that's scary.
It is. The advice isn't never take antibiotics, but it's be aware of this specific class. If a doctor prescribes a quinolone, ask if there are alternatives, especially if you have a history of mental health issues.
Vital information. Okay, what else systemically?
Long-term use of corticosteroids, like prednisone.
Oh, them.
They directly mess with your HPA axis, your body's main stress response system. They also promote gut dysbiosis. Basically, they put your body in a state mimicking chronic high stress, which is terrible for depression.
Right. Anything else dietary?
What?
Wrapping this all together, for someone really struggling with that resistant label.
The big takeaway is, it might not be that the standard treatments failed you. It might be that they weren't targeting the actual root causes for you.
The MTHFR, the gut imbalance, the inflammation.
Exactly. It's often this interconnected web. Addressing these systems, genetics, gut, inflammation altogether, that seems to be the key to potentially breaking through that resistance.
So understanding your MTHFR status, knowing 90% of serotonin comes from the gut, realizing how inflammation hijacks things, that's the real map.
That's the map. It gives you areas to investigate with your healthcare team. So the challenge for you listening is, which one of those action items feels most doable right now? Exercise, getting some sun, looking into CBT, cleaning up the diet. Pick one to start with today.
And one more time, the crucial reminder.
Absolutely. We have to say it again. This information, this research we've talked about, it's to help you ask better questions and have informed discussions with your doctor, your therapist, your registered dietitian.
It is not a DIY treatment plan.
Definitely not. Don't stop your meds. Don't start high-dose supplements without guidance. Your health and safety rely on professional medical care tailored just for you.
Right.